Hello, everyone. We are going to talk about lesson three, and this is be your third week of class, and this is covering media types that are used in networking. So we're going to go ahead and go through and look at some of these slides and discuss networking. So here are the objectives. You can go ahead and browse through these in your spare time, but you can take a look here that these are involving copper cabling and its properties, and then the exam objective topics down below. And we're going to hit some more media and then fiber optic cabling, the types of fiber optic cabling, then shows the exam objective below there. Wiring distribution closets, well, wiring distributions in particular, and the type of connectors and wiring distributions that are part of that topic. And then finally, we'll go ahead down to wireless media, and we'll discuss some of the wireless standards and hardware that is used in wireless media. All right, so first things we're going to discuss is how cable is denoted, and you may have remember me mentioning in class the other day, uh, 10 base T or 10 base 2 or whatnot, and that involves these numbers, these variable letters and numbers here, like this N right here. That would be the refers to the signaling rate in megabits per second. So example down here is 100 base X. Okay. Um, so signaling in the middle stands for the signaling type, either baseband or broadband. So it would be referred to as 10 base, as you see right here. And X is unique identifier for a specific Ethernet cabling scheme. It depends on the scheme. And we'll take a look at those in the next slide here. Maybe not. Not yet. We're going to talk about those in a bit. I know they're up in coming slides. So twisted pair cables are one of the cable types that you are going to be dealing with the most. And twisted pair cables, you see it consists of multiple individual insulated wires twisted together in pairs. Now the twisting of these wires minimizes the interference or crosstalk, and it is necessary to have a certain amount of twist in the pairs to prevent um, crosstalk from happening from other wires and whatnot. And this is the amount of twist is going to delineate how much it's protected against or the distance it can go without getting interference and whatnot. And there's also shielded twisted pair, which has a metallic foil like shield placed around the wires, and that's just it gives an extra protection. The metallic foil protects against more crosstalk attenuation and whatnot. And then there's a unshielded twisted pair, which is a twisted pair without the outer shielding, obviously. So let's take a look at the unshielded twisted pairs real quick here. So you may or may not have seen these wires before. And it says why unshielded twisted pair is preferred in modern Ethernet network configurations. Well, it's cheaper. It's easier to work with, and it allows transmission rates that were impossible 10 years ago. So I don't know if that's exactly accurate 10 years ago, but maybe these slides were made a little older. But this unshielded twisted pair, I remember back in 1997 or so, started coming out with unshielded twisted pairs, and it was very popular back then for getting those speeds that you weren't getting in the other types of media. All right, so move on a little bit here. So now the connectors that connect those unshielded twisted pair and shielded twisted pairs and those types of wires together, you use a RJ or registered jack connectors, okay? And you probably have seen these around. If you've ever connected your computer to a modem or whatnot. But let's go ahead and look at the different types. There's RJ11, which was used for phones. Okay, so RJ11 is originally used for phones. It's actually an RJ12 as well. It's not listed on here, which has like a modular little notch on it, which prevents it from getting plugged into to something it shouldn't be. And then there's RJ22s, which is used for handsets or of older style phones. And it's going to be like an RJ11, but a little bit smaller. And you still can see these around used with handsets for phones, like VoIP phones and whatnot. And it's because those connections, those analog connections from the phone to the handset are okay to use those types of wires and jacks. It's going on further that you have to use different types of connections. So RJ45 is the one that we love and use today. Um, it's used in Ethernet data networks. It uses the 4 pairs of wires for a total of 8, and it's usually associated with Cat3. When we talk about, we don't call it category. We call them cats. Cat 1, Cat 2, Cat 3, Cat 4, Cat 5e, Cat 6. So Cat 3 or higher UTP wire. Now, Cat 3 is pretty obsolete at this point, but I think they mentioned this a little bit coming up when we talk about the categories. But this was very popular back in the 90s, and it is no longer really being used at all. You can use it for 10 megabit or maybe even 100 megabit connections, but it's not a very reliable or protected or twisted enough to carry the higher bandwidth. So let's go ahead and move on here. Okay, so there's RJ connectors. Okay, here they are. And this is what they look like. So category cabling. Um, so the number of twists and the direction the twists turn in a given meter or wire varies according to how much and what type of interference the twisted pair wires are trying to minimize. Twisted pair wire is rated using categories, Cat followed by a number. Common grades of twisted pair wires used in LANs are Cat 5, Cat 5e, and Cat 6. These are the common ones used today. The older versions are no longer really being used. So category cabling has standardized jacks, and this is what they look like. And these jacks right down there, you're looking at right there, is a modular jack, okay? And that can be plugged into a patch panel or a wall outlet or whatnot that takes these modular jacks that are sort of universal these days, and that will allow you to connect to other patch cables to connect to a switch or a computer at the desktop level. All right, so here's a look at the common categories of twisted pair cables, and you remember I said that, everything here is pretty much out of date here. All those categories are no longer really being used. See, they all say they're obsolete here. Cat 5, they're saying is popular but replaced by Cat 5e, and that's true to a sense because Cat 5 is it's still in use, but it's really being replaced by this because it's actually become cheaper for them to make this version. As you overproduce, the prices go down. So the 5e has come down cheaper than it is for Cat 5. Now Cat 6, which is become very popular because of its ability to handle the gigabit Ethernet standards of 1,000 and 10,000 megabits per second, it's going to stay expensive for a while. So, but if you're looking to implement a gigabit Ethernet infrastructure, this is the way to go. All right, here's another look at unshielded twisted pair, the way the wires are twisted. Okay. All right, so this brings us into the TIA EIA 568 standards. Okay, so there's the TIA EIA. I'm just gonna keep saying that, but it's the 568 A and Bs. And all there is to it, these standards, is the way that you wire the cables into the jacks and onto the modular ports. So what does that mean? Well, right here you see the A standard is pins 1, 2, 3, and 6, which is the same for both of them. But on the A standard, you're going to use green, white, green, orange, white, and orange wires. So you're going to only use those two pairs for the transmission and receives, okay? But in the B standard, you're going to be using orange, white, orange, white, green, and green wires. All right, so that's the differences. And these things are usually color coded on the jacks or the patch panels where you're punching down. And I'll tell the two different standards because these are the only really standards we use today. Okay, so go ahead and take a look here at this jack pinout standards right here. So the 568A, you can see that 1, 2, 3, and 6. Okay, so these guys right here and this guy right here, all right, are using orange, white, I'm sorry, green, white, green, orange, white, orange, okay? And then on the T568B, you're going to see that we're using 1, 2, 3, and 6 as well, but it's a little different. It's orange, white, orange, green, white, green, okay? And all this is to keep a standard or standardized method of cabling your network throughout the whole network. So if you're going to use B, go B the whole way. And that seems to be the common thing as people have been using the B method. All right, so let's move on here. All right, so some types of commonly used cables, straight through cable, which is they're saying 568A, and then crossover cable is 568B. It's not exactly accurate, but rolled cable is a rollover and a hardware loopback. All right, so let's go ahead and take a look at these cables individually. So the straight through cable connects devices with dissimilar functions. A host or a computer to a switch or a route, or I'm sorry, a switch or a hub, and then that would be the host, and then a router to a switch or hub. All right, so that you use a straight cable for. You have 4 pairs or 8 wires in the cable. 2 of those pairs, 4 of those wires carried the data, and that was what we talked about earlier with the 1, 2, 3, and 6. Each pin connects directly to the pin of the same number on the other side of the connection. Okay. Now we talk about a crossover cable. So a crossover cable is basically the straight through on one side, and then the other side is swapped the wires to the opposite pairs. Not the opposite wires entirely, but the opposite pairs. So I'll show it to you in a second. But here, it connects devices with similar functions. The same 4 wires used in a straight through cable are used in a crossover cable, but arranged differently. Crossover cables can connect a switch to another switch, a hub to another hub, a host to another host, like another computer and a computer, a hub to a switch, or a router directly to a host. Okay, so let's go ahead and take a look at the wiring diagram. All right, and here it is, a Ethernet crossover cable wiring. So in this one, what we do is, if this is pin 1, this is 2, this is 3, this is 6, 1 and 2 are transmitting, 3 and 6 are receiving. What we're going to do is we're going to swap the receives on one side with the receives on the other. So 1, 2, 3 on 6 on this side go down. Let's see. Well, I'll see if I can follow you down here. So 1 will go down here to pin 3. All right, and then 2 over here will come down to 6, and then 3 over here goes up to 1, and then 6 over here is going to come up to 2. So we're in essence we're just swapping the pairs. 1 and 2 go to 3 and 6. 3 and 6 go to 1 and 2 on the other side. That's all there is to it. Crossover cables are used only in Ethernet UTP installations. It is possible to connect 2 workstation NICs or a workstation and a server NIC directly with a crossover cable. T1 crossover cable is another specialized crossover cable used in T1 applications, commonly used in WAN networks. We're not going to worry about that too much right now, but it is possible to connect two T1 type devices or T1 port cards on routers to each other using a T1 crossover cable. This is something you're more likely to use in a lab than you are out in the field. And we'll talk about that later with why that's not necessary. Um, so getting back to this point right here, possible to connect two workstation NICs. You can actually have two computers. You know how I draw. It's awesome, isn't it? So that's a computer right there. And then there's a computer over here. All right. And that computer's over here. Right there. All right. So it is possible to have these two computers connected to each other directly without using a hub or a switch. Just use a crossover cable to connect the two of them. And then you can assign IP addresses manually and then communicate with each other just like that. All right, moving on. So here we take a look at a diagram of when to use a straight or when to use a crossover cable. Okay, so like again, if you have a switch here, you can go a switch to a router using a straight through cable, a switch to a computer, so on. And then over here on the crossover, if you want to connect the two switches together, you'd need a crossover cable. A switch, and this is the diagram for a hub right there. So if you wanted to connect the switch and a hub together, you would just use a crossover cable, and then hub to hub, same thing. Router to router, you would use a crossover cable, absolutely. You may end up doing this in the lab one day. That was a really horrible circle, by the way. Sorry about that. If you wanted to connect a router directly to a computer, if you're doing it in a lab, you'd use a crossover cable, and then computer to computer, a crossover cable as well. All right, so we come to the rolled cable. They're calling it a rolled cable. It's actually a console cable that we know it from today. Now, this is one right here. This guy right here is a Cisco console cable that comes with most devices. I have a ton of those sitting in a box over here, and the school has tons of them as well. And right here, you see this over here is an RJ45 type connector right here. Okay, and what that has is the wires rolled in there. 1, 2, 3, 4, 5, 6, 7, 8 are lined up in there. And then they go to a certain pinout on this connection right here. And this connection is a DB9 serial connection. And they are wired, we're not going to go into the wiring patterns, but they are wired on here to a certain rollover method. But it's a little different for serial. So what this is doing is it's not used for connecting Ethernet devices. This is used for connecting to a router's console port, and that's why we usually call them console cables. Used by a WAN engineer to program or configure a router. Switches have a similar port, so you can end up configuring a switch or a router with these things. I'm going to go back a slide real quick here. So you would use a console cable to connect to, let me go ahead and erase my screen here a second here, erase all ink. So you would use a console to connect to one of those guys or one of those guys because they'll have a port on them just for console cables, and that'll let you connect using a terminal program to configure the device. And if you get into if you want to go on later into networking and do Cisco networking and whatnot through the school's academies, you can learn a lot about Cisco networking and you'll get to use these devices. All right. Okay, so moving on here a little bit. All right, so the final connector we're going to look at is hardware loopback, and this is a not very commonly used by you and me. It's a way to redirect data flow. You can actually take one of these and plug them into your network card on the back of your computer, and it'll loop back the signal from the receives to the transmits to say, or transmits to the receives, I should say, to trick your network card into thinking there's a live connection going on. And it lets you do some network testing if need be to make sure your network card's working properly, or your IP stack's working properly and whatnot. But you can see that right here. It says it can use loopback to trick PC into seeing its own output as input. And you use this loopback plug device. So let's go ahead and go move one slide up and we'll take a look real quick. And this is what they look like. And you can see in here, I mean, you can't see it too clearly, but what you see is you see this cable going here. It's going from 1 to 3. And you have 2 going to 6. All right, and then over on the other side, it has the same thing happening. All right, and it's just creating a little illusion that you're connected to a network, right? All right. So now let's take a look at some shielded twisted pair real quick. All right, so shielded twisted pair looks like you unshielded twisted pair cable, but it adds extra shielding, and that's that foil right there around the wires and the cable. And it's no longer popular in use. It's just the production cost is not worth the production the reduction in um, signal because there's better solutions out there these days. All right, so the next thing is coaxial, coaxial. I don't know how to pronounce it, but this cable right here is a center conductor made of copper. So you have a copper thick copper wire in the middle, and it's surrounded by a plastic jacket. If you ever cut into a coaxial cable, you'll see there's the thick copper line in the middle. Then it's got like a foamy type of plastic around it. And then it may have some metal. It usually has a braided metal shield, like it says it right here, actually. Braided metal shield. And the shield is covered by some PVC or Teflon. All right. And then the Teflon type covering frequently referred to as plenum rated coating. We'll talk about a little bit about that. Oh, we're going to talk about it right here. It does not release toxic gases if it catches on fire. So you need a plenum rated coating for when you're going to, it's for building codes. Specific building codes will require these coatings because if the building catches on fire and the cables start burning, plenum rated coating does not release toxic gases. So the people won't burn. I mean, the people won't die of gases, but they may die of burning buildings. It's better to not have those toxic gases, I guess. So cool. All right. So here's a look at some of the coaxial cable specifications. RG58U, RG58AU. You may have heard me talk about these yesterday in class. This is 10 base 2 is the RJ58AU, and we used to refer to it as thin net because it's a thin cable. Then it's 10 base 5, okay, and this is a thick net that we used to call it, and this is RG8, okay. So it looked like TV cable, okay, but it's not exactly. Then there was RG59, and that's the cable television wire you see. It's got low cost short distances. All right, and then we have RG6. It is the stuff that's pretty much used these days for cable television, cable modems, longer distance than RG59. Uh, Sometimes it can be used for power implementations because you can carry power across there. You may have seen a power amplifier on the side of your house installed by the Comcast or whoever your cable company is, and these are usually using the RG6 standards. And then there's RG62, which is ArcNet, and that's obsolete. Okay, so here's a look at the cable on ThinNet. This is that 10 base 2 stuff. It's a thin coaxial cable, and it's rated at about 10 megabits per second for up to 200 meters or 600 feet-ish, maybe almost 700 feet, but we refer to it in meters. And it's got the copper core, then it's got a little insulation, then it's got some wire insulation, and then it's got an outer plastic jacket. Looks a lot like the coaxial cables you see on in your house. Okay, but these cables use these BNC connectors. Okay, BNC British Naval Connection connectors. I think that's what it means. Something about British Naval. One of those trivia questions if you ever get asked. What's BNC stand for? Something to do with British Naval. Look it up. It's used with thinnet cables, okay, and this is what they look like right here. And they're modular. They go in and they pop in there and they just screw to the right a little bit, and that holds them on there. They did easily pop off if somebody went ahead and kicking wires around. So uh, let's take a look here next. Okay, so there's the F connector. F connectors are usually used on coaxial cables in broadband and your home cable television. You have seen these around. All right, RJ59s. Coaxial cable is used for low power video and audio transmission, connecting your DVD to your TV. I mean, these days this is kind of outdated because I don't think anybody uses RG59 to connect their DVD to TV. We're all using HDMI or might still be using RCA jacks, but those are better quality and easier to come by and than the lower quality coaxial cables. RG59 can be used for data runs that are longer than 100 meters. Unshielded twisted pair limited to 100-meter data runs. So see where that's an advantage. RG6 is used for cable TV inside house as well as from the external drop point into the house. Also used in fast broadband internet connections. So if you have Comcast, you're using RG6 right now. All right, so broadband over power line, BPLs. Okay, it's a 1901 IEEE standard. It's for power grid and power cables carrying electricity and data. Uses the same cabling as the power in your house, and it's not available in the United States. Third world countries only. Okay, so moving on to serial. So serial means one bit after another is sent onto wire or fiber and interpreted by a network card or other type of interface on the other end. Each one or zero, what does that have to do with, oh, the bits? Okay, remember we talked about that in class. So each one or zero is read separately and then combined with others to form data. Examples, the recommended standard. You'll normally see it referred to as the RS-232s. And that is the cable that I showed you going back. I'm going to shoot back a couple slides here. Couple, more than a couple, more than a few. There it is. There it is right there, that RS-232 console cable. Okay, that's what it's used for. Let me go back all the way up. Okay, so the RS-232 or the universal serial bus is another example of serial. USBs are the common ones you'll be seeing used today. So USB, default built-in serial bus for most motherboards. USB can support up to 127 external devices. Connect a USB peripheral. You can connect to a USB port on the PC or to a USB hub, then connect to a USB port on the PC. You guys are all pretty familiar with that. Let's take a look at the different standards. So there's the 1.0 USB. I still remember every time I think about the original USB, I think of when it was like 1998 or 99 when Bill Gates got on TV and he plugged a USB cable into a Windows 98 computer and it crashed and everyone laughed. It makes me happy again. So that's the USB 1.0 standard, and then they came out with the 2.0, and the speeds just jumped up so much. Maximum data rate of 480 megabits per second, which was amazing. Everyone was like, I love it. And then 3 came out a few years ago, and I tell you, I have a 3.0 terabyte external drive, and for transmitting a 4 or 5 gig file, it is pretty darn good. So it is a pretty good standard that they came up with, this 3.0 transmission rates. Not the normal serial, if you remember serial from years ago, and it's not the not your father's serial. So moving on. So I don't know why we jumped around here, but we're coming back to plenum. So plenum versus non-plenum. Plenum is actually the space between ceiling of one story of a floor and the next story. So that's the crawl space is called the plenum. Cables run through plenum. Okay, so these cables must be plenum rated, and they must be composed of materials that do not release deadly gases when burned. Insulating material in the cable cannot burn so quickly that it acts as a wick and just starts a big fire. So we don't want that. That's what the plenum stuff has to do with. All right, so we're done with that. So now we're going to move over here to problems and limitations related to copper. All right, so we're going to deal with electromagnetic interference, or EMI, speed, distance limitations, and duplexing. So let's go ahead and take a look here. So EMI is when two wires next to each other create a magnetic field, and the result is noise. Okay, copper media interference, called EMI, can result in this term I've been using a lot, and that's attenuation, also crosstalk, and security and electromagnetism. Electromagnetic magnetism. 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 Close enough. All right, so speed. So bandwidth. Bandwidth is the amount or number of signals that a wire can carry. Um, the latency is the delay in time that it takes for a signal to get across the wire. And then the throughput is the amount of actual data carried at any given time during a connection. So the bandwidth is the amount of number of signals that a wire can carry. But the throughput is the amount of actual data carried at any given time during a connection. You may have a 50 megabit connection from your provider, okay? But your throughput may be different because of other people in the area sharing that line. So you may only have 41 megabits when you do a speed test. And then you'll call Comcast and say, hey, why do I only have 41 megabits? I'm paying for this and this. And they say, well, it's not guaranteed. Okay. And this is why, because they're going to have things like other people in line. There may also be issues with latency that are happening, slowed connections because of too many people in the line, or interference, or they may have an outage or something like that. So that's why they tell you it's not guaranteed. All right, so distance limitations. So some cables are prone to attenuation, which is caused by distance signals have to travel and the medium itself. Noise cable on cable contributes to attenuation. Cables have a maximum segment length to reduce attenuation. Okay, so after a certain amount of time, we're going to start having attenuation issues on these wires, and that's why they tell you unshielded twisted pair right here is I think I told you like 300 feet, but it's 100 meters, and it's just over whatever 100 meters break down to, it's 328 feet is what they say here. All right, now this is just for unshielded twisted pair. Every single cable has its own rated limits. All right, so here we're talking about duplexing. We talked a little bit about duplexing in chapter 2. Duplexing is, here's the three different kinds. So you have simplex, which a device can broadcast or receive, but not both. That's not common. Half duplex, where a device can send or receive, but not both at the same time. And then there's full duplex, where devices can send and receive communications at the same time. All right, so moving on here, let's see. All right, so fiber optic cable. So fiber optic cables transmit signals using light impulses rather than electricity. They are immune to EMI and radio frequency interference, okay? Because they're using light. Works by allowing light impulses to be carried through either a glass or plastic core. Is single mode fiber or multi-mode fiber? Okay, so those are the types of fiber. So the pros, they're immune to EMI and RFI, and they can transmit up to 40 kilometers, about 25 miles on a single hop. One run can go 40 kilometers. That's pretty sweet. But the cons of that are it's difficult to install. It's more expensive than twisted pair. It is the troubleshooting equipment is expensive, and it's more difficult to troubleshoot. Because trying to find that really long wire where the break is and what exactly is going on could take a lot of time and money. I invite you to go ahead and take some Google searches out on fiber optic cabling to take a look a little bit more into it and learn a little bit more into it if you'd like to. It's a little niche of this field that's important to high-speed transmissions. All right, so there's multimode fiber. And that's a type of fiber optic cable that uses light to communicate a signal. Light is dispersed on numerous paths as it travels through the core and is reflected back. A cladding is used to line the core and focus the light back onto it, and it provides high bandwidth at high speeds over medium distances, about 3,000 feet on multimode. Single mode is very high speed, long distance fiber optic cable. It's got one or two strands of fiberglass that carry the signals, and lasers are the primary light sources. And these span very long distance because it can transmit data 50 times farther than a multi-mode fiber at a faster rate. So let's talk about a little bit about these connections right now. All right, so the SC connectors, these are latched and they work with single mode or multi-mode. and they last for around 1,000 matings. Matings. What's that all about? Well, this is the male connector right here, and this is the female connector right here. And when they come together, it is mating. Okay. All right. So fiber optic straight tip connectors, or STs, is one of the most widely used fiber optic connectors and uses a BNC style attachment. So style, in essence, this is the male connector right here, and it plugs in. We don't have a graphic of it, but that guy right there plugs into a port, and you just push in and screw to the right a little bit, and just turn a little bit clockwise, and it'll catch on these little latches right here, and it'll stay in there, and it's a lot more sturdy than the SCs. All right, we're going to look at the next one. It's going to be the form factor connector, and that's allows more fiber optic terminations in the same amount of space than its standard size counterpart. Two most common versions are the MTRJs or the LCE connectors. So let's take a look at the LCs first. Okay. So the fiber optic local connector is a newer style of SFF fiber optic connector. Fiber channel connectors is the FC adapters used for fast storage area networks and gigabit Ethernet adapters. Okay, so you look at it right here, and it's just got right here this little fiber end coming in here, and that pushes in, and that guy comes in and he goes. That's a guide right there, and in these channels they're latched in to the gigabit connector or GBIC or whatnot, and it just pops in there and it latches in and it locks. And then there's a release on the top of the connector, which we don't have I'm sorry, we don't have a diagram of or a picture of, but just pop it out and then they'll pop right out. But usually you just pop these in and that's the end of that. All right, wiring distributions. All right, so many components involved in wiring a computer or network. Cables, connectors, cross connects, patch panels, jacks, devices, connectors go in, and more. All right, so the vertical and horizontal cross connects. All right, so cross connect is a location within a cabling system where all the wires come together. Cables that run from communication closets to wall outlets are horizontal connect cables. And a patch cable is any cable that has a connector on both ends and is used to connect a network device to a network device, a wall jack to a network device, or a network device to a patch panel. All right, so these are some bolded things you need to look into a little bit. When you're reading in the text a little bit more about them, make your little notes off to the side about these guys because they're going to come up on your exams and whatnot. So the cross connect again is the place where all the cables come together and where we may wire them in the closet for connection to the end users. Okay, and then the cables that run from communications closets to wall outlets are the horizontal connect cables. So we get that to the wall outlet that's on the wall. Okay, and it's got the little jack in there. Okay, so that's where the horizontal connect cable comes to, and then we finally come to this patch cable. All right, so now you have your computer over here. All right, and let's give a little keyboard over here, and then maybe a little mouse. Okay, so you got this keyboard, this computer over here, and it's on your desk, and there's this wall outlet, and you take a cable that goes from the wall outlet to your computer. That is a patch cable. I know I'm an artist. All right, and then finally is the vertical connect cable, and these are the backbone cables that connect equipment rooms, telecommunication rooms, and other physical termination points. These are the ones that connect rooms to rooms and rooms to main points. You don't see these most of the time, but these are very important backbones for the network. All right, so you may have heard me say the word patch panel before. Is what we're got to it now. All right, so rack or wall-mounted structures that house cable connections. So that cross connect we talked about, where we bring all the cables in, all the cables need to be mounted into something, okay? And then that something is going to be a patch panel. There's a few different types of patch panels. There's 66 blocks, 110 blocks, DMARC extensions, smart jacks. All right, so let's take a look at a back view of a small patch panel.
You may have seen these now. It looks like a switch, right? No, it's actually just a piece of metal with some plastic inserts in it. And what we do is we bring the cables in, and then we bring these cables in, and we do a little splicing, and then we do is we use a punch down tool to punch those wires down into these blocks in the correct wiring pattern. And you can't really see it right here, but it's like orange, white, green, stuff like that. All those things are there to show you where to punch them down to. So you punch them down in there, and then on the front side, you use what to connect to something else. Use a patch cable, okay, to connect to maybe a switch or something like that. Okay. All right. So here's a 66 block. We don't really use this for network communications. These are actually still used today, but not for networks. They're used mainly for telephony, like analog lines coming into the building. You'll see these right here. So what happens is these analog lines, the phone company may bring a couple lines in, and they'll wire them up the back of this device, and then comes up through here, and then they'll punch them down into the side right here. And each one of these is a pair of wires for the phone. Okay. And then what they'll do is they'll put this thing right here in the middle, and that's a little jumper. Okay. So those jumpers will connect this side, okay, to this side. All right. Now what happens on this side is now the phone company has you wired up with your lines here. That's called the demarcation. They're done. So what you would have to do is you'd have to bring your wires from your phones. Okay. All right. So you got your wire from your phone, you're bringing it in here, and you're going to punch down the two wires here, and it'll patch over to there, and then you'll have phones ringing. Yay! Okay. This is considered legacy, but you'll still see them a lot in phone closets for the analog phone lines. All right, so I'm going to talk about the MDFs and the IDFs. Um, so the main distribution frame is a wiring point generally used as a reference point for network and telephone lines, installed in building as part of a pre-wiring process. This is completely accurate that when a building's being built, they will build a closet that is just for wiring. And they may have pre-wiring, or they may just have big pipes installed from certain areas. So that way it's easier to pull wires through them later. You'll see this a lot in newer buildings. Intermediate distribution frame is located in an equipment room or telecommunications room, and is connected to the MDF by a backbone cable. Here's a look at a 110 block. It is used for computer networking, somewhat. Um, it is. It's what's gonna. We don't really use these anymore. These 110 blocks we don't use anymore. We're gonna use more of what you saw in the beginning when I showed you that patch panel, where the jack's like that, and then on the back of it, it had that section where you could do the punch downs. Okay, we'll just back up to it real quick so you can see it actually, right here. Okay, so again, one side has the RJ11 jacks for phone connections or RJ45 jacks for network connections. Um, we don't really use the 110 blocks for that anymore, though. All right, so demarc or demarc extension. Demarc is a demarcation point, is the last point of responsibility of the service provider. Service provider, this is universal with any service provider. So what may happen is the Comcast is going to come in, they're going to put a connection on the side of your house, okay, where they'll have you can screw in your jacks. That's their demarc point. Um, the phone company may come to your house and they'll install a little jack on the outside that where the wires come into, and you may be responsible for doing the rest from there. The phone company would also come into your office and they would set up um, a jack, maybe a 66 block or a device for handing off a T1, and this is also called a demarc or demarcation point. Demarc extension is a length of copper or fiber that begins after the demarc but does not reach all the way up to your office. Most often used when the external service enters your building somewhere other than your MDF. So they may bring it into your building at the front office, but they need to do a demarc extension to get it into your MDF closet. That's what demarc extension is. All right, so what I talked about with where they actually hand off to you is not necessarily a demarcation point. They're going to give you something called a smart jack, and it's called an NID or a network interface device. It's usually owned by the PSTN or the public switch, AT&T or whoever your phone provider is. And then it's a special network interface often used between the service provider's network and the internal network. This is going to be for digital communications, and the service provider may install an NID that has power that can be looped for testing purposes. All right, so that finishes smart jack. So moving on, we have next section is verifying the correct wiring installation. So some issues that you can deal with when wiring networks is issues with copper cables placed too close to a magnetic source, or cable jackets being ripped when pulling the cables through the plenum areas. Cables cut wrong or extended beyond the minimum length for their type. Fiber optic cables handled roughly or poorly installed. And I can tell you that those cables, you're going to see them, they're orange most of the time, and they are very fragile. And if you bend them too much, they will break. And that's it. You're going to have new cables ran. Um, and down here on the bottom says test, 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 and again. And yeah, and that's a good idea. You can some of the things you could try for troubleshooting are things like swapping out another cable, or if it's a long run, if there's multiple runs, you can try seeing if the other run's working, and swap that out on the devices to see if that's okay. Um, and that's about all for verification. Um, it says best practices: install more cables than necessary. If a cable goes bad in the future, you can have an extra cable, and keep detailed records. Now, the problem with installing more cables than necessary is, of course, there's a cost with that. So the more cables you run, the more expensive it's going to be. Verifying the proper wire termination. You can inspect the installation. You can verify that all the wires are terminated properly in the right order. That comes down to your pinouts, making sure they're in the right spots. Fiber optic termination requires specialized and expensive equipment and training. So that's usually you're going to have somebody, if you have to have a fiber run set up or fixed or something, you're going to be hiring somebody outside because there's special training involved with blow torches and burning shaping the tips so that the fiber goes into the end pieces correctly. Terminate new connections using the appropriate tools. So, all right, so moving on to wireless media. So we talked about this in class the other day, and this is the 802.11 standards of wireless right here. All right, that includes wireless A, wireless B, wireless G, wireless N, and the new one that's not listed here, and that's wireless AC, which involves the gigabit Ethernet connections. I'm sorry, wireless connections. All right, so let's go ahead and take a look at the next. And here we got 802.11's most prominent standard for wireless LANs, addresses and distance, speed, latency, frequency, channels, channel bonding, and MIMO. So 802.11a, this is one of the original standards that were out for wireless, and the theoretical maximum throughput is 54 megabits per second, but it's realistically more like 22 megabits per second. Maximum indoor distance is about 50 feet or 15 meters. Outdoor distance about 100 feet or 30 meters. And this uses the 5 gigahertz radio frequency range. And there's 8 non-overlapping channels in this range. So then we go to the B standard, and that involves a theoretical throughput of 11 megabits per second. So you're going to notice it's a lot less megabits per second than the A standard that I just showed you right here. But and also you're realistically looking like 2.5 megabits per second. And this came out in the 90s, and it was good. It did a good job of for the speeds that we needed back then. But when programs and computers started moving data at larger speeds, it just wasn't enough. Maximum indoor range and distance is about 150 feet or 45 meters. So you're going to notice this is a little bit better distance indoor than the A standard was. And maximum outdoor is 300 feet or 90 meters. So a lot better range outdoor as well for the B standard. It uses the 2.5 gigahertz radio frequency, and that's why it was a little bit better. And then it has 3 non-overlapping channels, and that's 1, 6, and 11. All right, so G came out in 2002, 2003. It was amazing. Uses the same frequency range and same channels as 802.11b. Has same distance capabilities as 802.11b, and the theoretical out throughput is actually 54 megabits, but really we were looking at about 22 megabits per second. And it's fully backwards compatible with 802.11b. That's why you'll see it listed as 802.11bg sometimes. Okay. All right. So just recently, in the last few years, 802.11 came out, and this is the 5 gigahertz range and 2.4 gigahertz frequency ranges. So use both of them. Theoretical throughput is around 300 to 600 megabits per second, but really you were getting like 100, maybe 200. Maximum indoor distance was 229 feet or 70 meters, so about the same as the BG was. Maximum outdoor distance is 820 feet or 250 meters, so that's pretty good. And this uses channel bonding. And this is where two or more adjacent channels are linked together. So they were using 5 gigahertz and 2.4 gigahertz channels bonded together to create a better speed. And it's been working pretty well for the last few years. Okay, and they're not going to show you right here, but the AC standard is the new stuff that is just been used in the last year or so. Only within the last year has the equipment really been coming out for it, and this is going to get you at gigabit speeds, and that's pretty cool. I don't know if everybody's ready for it just yet. I mean, I'd like it, but I don't know if everybody's equipment is ready to be upgraded to it just yet. So tying it all together, it's important to know what types of media connect to specific devices and in which order. Connecting the wrong media type to a device or connecting media in the wrong place is going to prevent your network from communicating. All right, so here's your summaries. Okay, so we talked about the Ethernet cable types and how you made 10 base T by using this formula here with the N, the signaling, and the dash X, 10 base T, 100 base FX, those types of cabling types were used there. COM cabling, shielded twisted pair, unshielded twisted pair, and then you had your grades of twisted pairs, which were Cat 5, Cat 5e, and Cat 6. We had issues with cabling when we had they're susceptible to EMI and interference. Fiber optic cabling transmits digital signals using light impulses and is immune to EMI and RFI. Good stuff, right? But it's more expensive. Fiber optic cabling is single mode fiber or multi mode fiber. And patch panels are rack or wall mounted structures that house cable connections. Types of patch panels included the 66 blocks, the 110 blocks, and then you have DMARCs and smart jacks. Wireless standards 802.11a, B, G, N, and it may not be on the tests yet, but AC is going to be there soon. All right, so that's all. If you have any questions, go ahead and give me an email at lewis.tanga@fscj.edu. Thanks for watching.